And this is problem 3 for our review for the Unit 6 test. This is talking about parallelograms. And the problems that we're going to be dealing with here with parallelograms, generally, you've got the things that are dealing with the lengths of sides. What we know about those is that opposite sides of parallelograms are congruent. We also know that when we're looking at diagonals, those diagonals bisect each other. Now, this one is going to be a little different because we have A and B for this. So in my head, when I set up equations, I'm like, well, what am I doing with that? Here's the part that you really kind of want to think about when you're doing any of these problems. When you're setting up equations, just recognize that because you're dealing with bisections, you're going to have two things that are split in half. Find the one that has the same variables. Like in this case, I've got B here and I've got B here. And then in this case, I've got B here and I've got A here. Ultimately, what you're going to want to do is find the one that you can use with one variable. Setting this up equal to this gets us nowhere to start, but dealing with it with finding the B here allows us to have an equation that shouldn't be too bad to be able to solve. So when we start this off, we can say that 5B minus 7 is equal to 3B plus 6. Now, when you're solving a system, when you're solving an equation that has something like this, first thing that you want to do is get the b's on the same side. So I'm going to subtract 3b from both sides to cancel it out over here and bring it over here. 5b minus the 3b is going to give me a 2b on this side. Minus 7 is equal to 6. Whoop, that's not an equal, that's a minus. Let's write it correctly. Equal to 6. Now I want to bring the 7 over to the other side. So I'm going to add that 7 to both sides, and I'm going to get that 2b is equal to 13. And then if I divide both sides by 2, I'm going to get that b is equal to half of 13, which is 6.5. Okay, again, we're getting these decimals. It's fine that we get decimals. Just be prepared for that when you're looking at it. Because when we solve this, what I'm going to want to do for this other side is to set this up in such a way that I can say, okay, this is a number that we found. 2a is going to equal that number, and we can solve it. It's going to be a decimal, guys, so just be prepared for that. So let's do the work for the B up on the top here. So let me see if I can start that off. I'm even going to see if I can change the color of this one a little bit. So for this one, I'm going to say I know that I'm going to be doing 3 times that 6.5 minus 5 to get the answer. Using my handy calculator, if I take that 3 times 6.5, I'm going to get 19.5 minus 5. And that is going to give me the length for that side as 14.5. So that means that this part here is 14.5. Since they bisect each other, this 2a will also equal 14.5. So I'm going to set up that equation right here. And let's go for a fun green color for that one. And we will say that we know that 2a is equal to 14.5. And if I divide both of those sides by 2, I can tell you that a is going to equal 7.25. So that gives me my b for the first part and my a for the second. Again, not too terribly off, not too terribly difficult, but definitely something to deal with. Now, that asks for problems to find the values of a and b. This problem b sucks. Not because we can't find the variables, because that should be fine, but that's not what they're asking for. They're asking for us to find jk, jl, and mn, this part. So I need to find the z to find this one. I need to find the y to find this one. And I need to find the x to find this one. All right, guys, I'll help you set them up. It is, I'm not going to lie, this is a dumb problem because it's just as much work to find the x as it is to plug this crap back into it. So we'll see if I can get past my hatred of problems like this as we start working. Let's do the z part first because we haven't dealt with the exterior part. This side and this side are congruent to each other because it is a parallelogram, which means then that what I can do is set up an equation by saying that 16z minus 4 is going to equal 8z plus 4. Okay, if I'm going to bring the z's over to one side, I'll take the smaller one and subtract it. 16z minus 8z will give us 8z here. So 8z minus 4 is equal to, gosh darn it, equal to 4. If I add that 4 to the other to cancel this one out, it'll move it over here. We get that 8z is equal to 8. If I divide them both by 8, I'll get that z is equal to 1. Holy crap, we have a number that's not bad. So in this case, if I plug in a 1 to this jk, which is what I'm finding here. Well, that shouldn't be too bad. I can show that work, or I could just tell you, hey guys, I can do math. 16 times 1 is 16. Minus 4 is going to give you a solid 12 there, guys. We got a 12 on that side. Now that I found Z and I found that side, let's see if we can find Y next. All right, so that'll be, I'll set that equation up here. The diagonals bisect each other, so we know that 4y is equal to 3y plus 2. This should actually be pretty fast. 4y equals 3y plus 2. I want to get the y's on the same side, so if I subtract 3y from this one, I'm going to get that y is equal to 2. Holy crap. Unbelievable, guys. Y is equal to 2. Now, if I take that 2 and plug it into both of these, that'd be fine. Really, it's not going to be hard, because what this is going to mean is that if I go right here, hey, let's think for a second. If I'm doing 4 times 2, that would mean that I'm going to have 8 right here. And 3 times 2 is 6 plus 2 is going to make this guy right here also maybe 8. So that the length of this JL is going to be this 8 plus this 8, or a happy 16. You guys got the idea there. All right, so now we've used this to find our Y's. We have used this to find our Z's. Let's find our X's. We're dealing with the same issue here where it's bisected. So I can tell you that the X plus 6 on the left-hand side is going to equal that 2X minus 2 on the right-hand side. All right, the only difference here is that I'm going to be moving the smaller x over this way. So this gets subtracted from both sides, and I'm going to get that 6 is equal to x minus 2. And then if I add that 2 to this side to bring it back, I'm going to tell you that 8 is equal to x. Not that hard for us to figure that part out. It now wants mn. So if I'm going to be plugging in 8 into this one right here, that means that this length mn is going to be giving me, well, let's see, 2 times 8 is 16. 16 minus 2 is going to be 14 for that one right there. So we have the length of mn is equal to 14. That means that we have everything that we have been asked for this problem. Now, y'all, that's a lot of crap. And it's all just setting up equations, seeing what you're going to do. I think that you might on the test have one where you do 2 of these, but I don't think you're going to have as many as this. So that takes care of these. I want to slide down so we can talk about the angles for a second, but I got to clear off my drawings first. A lot of stuff out of the way there. And so let's look at the angles that we're looking at here. Trapezoid problems will be the next video you're going to be looking at, but this is sort of the way we're dealing it. So it wants angle H. Now we know opposite angles are congruent to each other. And we also know that consecutive angles are going to be supplementary. Here's the problem. It doesn't just want angle H, it also wants N. So what I have to do first is find M, so I can find out what this is going to be. Then I'm going to subtract from that from 180 to get this guy. Then I'm going to say that that's what this is going to be after I plug it in. Guys, pain in the ass is definitely the description that I would use for this one. But let's do it. So as we start talking about this, I can set these two equal to each other. I know that 2M plus 31 is equal to 7M minus 29. All right, first thing I'm going to do is subtract the 2M from both sides, and I'm going to get that 31 is equal to 5M minus 29. I'm going to add the 29 to the other side, and when I do that, I'm going to get that 60 is equal to 5M. And if I divide both sides by 5, I'm going to get that 12 is equal to M. All right, so far so good. Now, I think finding this angle here is going to be important so that we can then subtract. So if I do this one right here, and if I plug a 12 in for M, 2 times 12 is going to give me 24. 24 plus 31 is going to be 55 degrees as this angle G. So if this angle G is going to give us 55 degrees, then I have to take from 180 to get what this angle K is going to be. The angle, actually, I can take from 180 to get what this angle H is going to be, because that's one of the things that we have to find. So 180 minus 55 is going to be 125. So angle H is 125 degrees, solid. Now we've got to use that to find our N because these are equal to each other. So with that, I'm going to come over here, change the color because you get bored with the same things. And I'm going to say that that 125 is equal to that 12N plus 11. Got to subtract 11 from both sides, which is going to give me 114. Well, that's not fun, is equal to 12N. I thought at some point in time they'd say, hey, this is going to work out really well. But nope, that's not what's going to happen here. So if 114 is going to equal 12n, then if I take 114 divided by 12, I'm going to get a number that is all too crazy. 114 divided by 12 is going to give me 9.5. Actually, wasn't that crazy. That is equal to n. And we have solved this problem as well. So that's a lot of stuff, but I think that gives us the ideas to what we need. And that should be enough for problem